Welcome back to in today's series of InOrder Traversal. So previously we have implemented the InOrder Traversal through recursion. That means we are calling one function again. So today in this video we'll be observing using the iteration method. So you must be thinking, what is iteration method? The for loop, the first time you learned, that is iteration method. So we'll be implementing this one like this. So first understand what's InOrder Traversal. So InOrder, this is the method of InOrder is, it follows: first we visit the left path, then we visit the root, and then we visit the right portion, and this is called the InOrder traversal. In the left side, and then we'll be visiting the right side, and then we'll be visiting the right side. So first try to understand, for all the iterations we'll be using stack. You might be thinking that why will we be using stack here? First, first try to understand. First, we have used the recursion, and through recursion, you have utilized this program. So when we have used the recursion, so this is very shame, and it actually calls the function again. In for loop, it keeps calling the same function again. So it also maintains a stack of itself. It also maintains a stack of again. It also maintains a stack of again, but it's inbuilt stack. So this is the inbuilt stack of recursion. Inbuilt stack, this is already inbuilt stack of recursion. But when we iterate, when we'll be utilizing the iteration method, we will not have this inbuilt stack. We have to provide our own stack from outer side, so we'll be using our custom stack. So now let's try to understand the main method, that how we'll be importing. So first, when we write the program, what you require is, we have to import the stack. So first we'll be writing the line like this: import java.util.stack, import java.util.stack. Cause first thing what we require in this program is a stack. That is, we need a stack, and that's why I'm drawing a stack. It is very important things in our program. Now try to understand this node. The node we are seeing here, this is not the architecture that this is like round like this. That is not the architecture. It has a different architecture that I have told you many times. So the architecture is like this. This is actually the node in its actual architecture. This is the left side, that is the right side, that is the right pointer, and the middle one is called the data pointer, that you already know. So what we do in here, that first we traverse the left portion. That means we start from the left side, and we keep entering the elements of left side. So first we enter the element 1, we get the 1, so we start from 1. So first we insert, that means we push this element into the stack. So first we'll be inserting this 1, so we insert the 1 like this. This is the 1, that one. So this is the actual representation in our program. I will not represent like this again and again, so I made you understand. This is 1. Now what we do, we again come to this here. We have done with 1. Now we will push this. We will be pushing the 2 into it. So now we'll be pushing this 2. So now we push 2. Once 2 is done, now we will again move to the end until we don't encounter null. So we will again push 4. Okay, now we came up to the 4. Now try to notice 4 is also like this. This is also having the general architecture of 4. General architecture of 4. And this is the left section. So our code will again move from here. It will again move from here, and it will encounter here null. Once it encounters null, we will stop them. We will no more insert. Now what will we do? We will pop an element from here. So now we will be popping an element. So once we pop this element, we will put here 4. So what we encountered? First we encountered here null. So we'll be writing this just null. First we encounter null. Then what we encounter? Then we just pop the element 4. So once we pop the element 4, we print the element 4. Once we have printed the element, try to understand. This is the left portion. And I got that left portion as null. Now that is the root portion with respectively, that is the root portion. So now root has been automatically processed null, and because we have popped this 4 here, it has been popped from the stack. And now after we have just popped this element, we visit the right side. We visit the right side. Encounter that this right side. Here the right side is not null because it is pointing to 3. So once it's pointing to 3, now again what we do is we update this. We get 3, that means that's the element. So according to the program, again we insert this tree into the stack. So again it is pushed back into the stack. And now at the end there is only 3 elements, and by that time all those elements will have already erased. So no element will exist here. Those all elements have been popped. So now we have the 3. We once get the 3, again we check in the left side of it that there is null. Again we encounter and we just keep a null. Then again we get 3 and again we get a null, so we stop. Now notice one thing, that we got so much null here. We just got so much null here. So all the null, 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 null. These nulls are the stopping points. These are the points in the code when we stop, when our program actually stops. So if we just print in the console, those stopping points and null will not be printed, because our program will work in such a way that it will just stop while it encounters null, and in other case we'll just get the value of it. So first, as per the program, if we just print it, we will get the 4 because this is left section, then the root 2, then 5, then the mega root 1, then 3. So it has printed 4 to 5, 1, 3. Now we'll be understanding the coding and we will implement it in the VS Code, and then we will look forward that if you understood or not. So okay, let's start by writing the program. So to implement this program, what we require, the important first things, we require the stack that I have already written, that import java.util.stack. So let's start by writing the same line. First we have to import the stack. So import java.util.stack. Keep in mind that always the package's name are in capital letter. This stack is always in capital letter caps. This is very important things to remember. Now first we have to implement the binary tree. So previously we have implemented our binary tree class like this. Class binary tree, class binary tree. So we'll be implementing the binary tree, and before that we have to keep in mind that we should have a another binary tree.java class already declared. Binary tree.java, tree.java, binary tree node.java. We need a file name binary tree node.java already declared, else our program will not work. Binary tree node.java. So how we create the binary tree node, I already have told you, I will not discuss here. So we will be utilizing this binary tree node, okay. So class binary tree. So now we'll be creating a root pointer with respect to binary tree node because we require it at the first. So binary tree node root. So now we have already created a root like this, which will be pointing to the root. Now it is just not initialized. It is, I mean, not no any value. So if you try to understand in terms of understanding purpose, it is just like this. That is pointing to root with value equals to null. Okay. So now we have created the binary tree node root. Now we'll be creating the function of InOrder Traversal. So we'll be renaming the function binary tree traversal as InOrder Traversal. So let's write the void InOrder Traversal. Void InOrder Traversal. And we take no arguments, and we also don't return because we print at this place. So first what we do, first we actually start proceeding from the root node. This is the root node from where we started. So first we did that, we check the base case, this stopping null case, that if we encounter null we'll stop that program. So first we'll be checking that case, that if our root is null, that means you have to think like a programmer, that if there is such a case where this is the case that root is null, so we'll be checking that case, that if root is null, that is if root equals to null, that means there is not actually a tree. So we'll be simply returning return, and our program Java will stop. Now once we have written the program, now we will create a stack because we require to create a stack for inserting all the elements. We need to create a stack for inserting all the elements, and where we'll be actually inserting the elements one by one. So for that we'll be creating a stack, and that's why let's create a stack. So we'll be just using the tree node type of data. So stack, and for that we'll be using this node, binary tree node, stack binary tree node, because in this stack we'll be storing actually that data. Stack that is equals to new binary tree node. So okay, now we have created the binary tree node, as you can see. So once we have created the binary tree node, now we'll be starting exploring the tree. So the tree structure is like this: 1 2 3 4 5. Now let's draw it in a small portion to understand for better purpose. 1 2 3 4 5. So always this starting point is called the root. That is called the root. So we'll be starting actually working from the root, but from we cannot actually move the root to here and here. Otherwise we'll just lose the tree. So we have to point. We have to assign the tree. We have to create another pointer for that. So we'll be creating another pointer just like this. Tree node, binary tree node, binary tree node, current node, and that is equals to root. So once we created the current node and we assign the value of root, so our tree actually becomes like this. Another current node pointer creates, and it also points to the starting of the tree, current node. And now you see it also points to this node, this starting node. It also keeps pointing. So now we are starting from the root and starting of the tree. So first we'll be starting that if our current node is not null. Now we'll be checking actually two conditions. That if our stack is this stack, if our stack is not empty, that means there is element like 4 1 2 4. So if there is element, we'll be continuing the loop as we know. And if in our current node, that is if in that side there is the value, then also we'll be proceeding a node. So we will be writing those two conditions, that while first condition, that is if our stack is not empty, and the second condition, that is current node is not null. So while current node not equals to null, that means current node is pointing someone. Or the second condition, that means our stack is not empty, that is stack dot is empty, and we want the condition that stacks will be full. So we'll be just applying stack dot not is empty. Till then we'll be running our program. Node not equals to null, and another is that you check if stack is not empty. So now our main core focus is to just approach, is to include all those elements one by one. So first we just pop this element 1 into here. Then our goal becomes to insert this element 2. Then we just proceed like this. First we proceed 1, then we proceed into 2, then we proceed into 4, and at the last here we actually encounter a null. And this null becomes our stopping point. That means where we stop the program. So can you just observe one similarity or one special things to notice here, that our program is continuously approaching this side continuously, and it's stopping only when it's encountering null. So for that, to approach continuous, we require something like a loop. So again we'll be applying a loop, and we will not stop the loop until we don't actually meet a null value. So let's write like this: while current node not equals to null, current node not equals to null, while current node not equals to null. So what we do, we just update, we just push one by one all the elements. We pushed 1 here, then we pushed 2 here, then we actually pushed 4 into the stack. So we actually pushed element one by one into the stack. So we'll be just pushing the current node. So stack dot push. For that we'll just writing stack dot push, stack dot push of current node, And once we push to the current node, that is first time we pushed 1, second time we will be pushing 2. So to push 2, we have to bring the current node into here. So we'll be updating the current node that is equals to current node dot left. So after applying this line, we actually updated to the left side. The code got left updated to the left side. So we handle both the caches. Now what we have to do with this is traversal. We want to fetch the elements according to the traversal, and what first we process the left element. So now we have to proceed. We have reached toward the last. This position is called the last. That is the last element of the tree. Once we have got the last element, now our goal is to actually pop the element. Now our goal is to pop the element and bring the element back of the it. So now we will be popping the elements of the end node. So we'll be simply again update the current node like this. So now we'll be writing the code for pop. So we'll be updating current node like this. Current node that is equals to stack dot pop. So once you apply this function stack dot pop, so what will happen? This was the stack of that one. The stack like this structure, and that was 1, then it was value 2, and then it has value 4, and this was the stack. So once you apply this stack dot pop, it actually pops the element and it actually brings the element 4 back. So we got the element 4 back. Try to understand. So we got the element 4 back. Now what we do, we just print the elements and the value because we are traversing. So we'll be printing the value. So system.out.println in Java, system.out.println, and then we'll be printing the value of this current node. So current node dot data, we can call it data or value. Actually this portion depends on what we have defined in our binary tree node, either data or value. This is the integer section. So now we'll be printing that 4, and now this time our console will be printing. In console we'll be able to see that our code has printed 4 for the first time when it has encountered this line. After we have encountered this line, what is our code focus? Our core focus is next to get this one. First we got the 4, now we want to get this one. So how we can get this 2? We have to think in mind. For that we will just update. We will just update the current node again into the right. So again updating the current node. So for that current node that is equals to current node dot right. So now we have updated the current node dot write. So now what happens when we just write current node dot write? Now again let's observe the program. You can see that here current node, first we faced the element 4 and 4 was stored here. So if we just encounter this current node dot write, we again get it null, and once we get null here, this null, so our code comes to that current node equals to null. So this condition now becomes equals to null. This is not executed, but this condition is executed, that stack is not empty, that if stack is not empty. So we see that if 4 has been removed from our code, there is already two elements 1 and 2. So there is already two elements. Now current node equals to null because we have encountered this null here. So now this section will not be executed, it will come in next section. And now again current node equals to stack.pop. So in this section this line will be executed, and again this two will be popped out, that 2 will be popped out. And now we'll be just popping the two elements because this line has been executed and this 2 is popped out. So now look, current node is having the value stack.pop. So current node got the value of 2. Now current node is having this value 2. So now the code line again tells that print. Now we have printed. Now second time our console will print the 2 once we encounter. After this 2, now again notice that current node equals to current node dot right. Now our pointer of the program is at the 2. It will move towards the right and it will encounter 5, and it will again insert the 5 into this. It will again insert the 5. So by now 4 and 2 has been actually popped out, they are not present. So this is how the program actually works in the code, and this is quite important and understanding program that we have written, and this is really very much amazing to understand. So let's execute the program in our VS Code and let's see if it works or not. So just wait a minute. Okay, now I have to start the VS Code. Okay, so now we'll be starting noticing the VS Code. So this has the binary tree node and public class binary tree node. So previously we have already implemented something like traverse tree by level. So this was a previous video. So we'll be implementing the same code here so that we don't have to work so much. And the public static void main. This section I haven't shown you. This is the section that is utilized to create the node. That is utilized to create the node. Okay. And now we see this is binary tree. So this is binary tree node. We have to create the node of that three data structure that I've already shown you. So everything is already declared. Now we start declaring that things we require. So first we require the stack. So we'll be importing import java.util.stack. And now this is void traverse tree by level. Now we'll be implementing the function what we name here, that this is void InOrder Traversal. So void InOrder Traversal, and we start writing the code. So first time what we have done in our code of there, that we have actually created the tree node root. So now we don't have to create here because we have already created this one, this tree node root. So we will just write this program from here as we require. So first we'll be checking the condition that if our root is not equals to null. So for that let's write if root if root equals to null. That means if you encounter root equals to null, that means there is only pointer. So return. We'll be just returning. Then we'll be actually creating a stack because we require the stack binary tree node. We'll be storing binary tree node. Let's see, the name is binary tree node here. You can see. So this one, stack binary tree node stack, that is equals to new binary tree node. Okay. So sorry. We are creating with respect to the stack. So okay. Now we have created the stack binary tree node for stack. Now we will be creating the current node that is required. So binary tree node current node, that is equals to root. And after that now we'll be checking the condition, that is if current node is not equals to null, that is equals to not equals to null, or not of stack dot is empty. That means stack is having some element. If it is having some elements, then we will enter. So first we'll be checking. First our goal will be to insert one by one all the elements. So we'll again utilize one more for loop, that while current node not equals to null. So while current node not equals to null, not equals to null. So what we will be doing here, if current node not equals to null, so from we'll simply just push all the elements one by one. So stack dot push current node. So all the elements will be pushed and we will update the current node, that is equals to current node dot left. So this will already insert. Now this loop will only stop when we reach the end, and once we reach the end we have to pop the elements back. So we will just pop the element back. So for that we'll be apply current node, that is equals to stack dot pop, and now it will have pop the element, and now we'll simply be printing this element, system dot out dot println current node dot data, and now we just printed the element. And once we printed the element, we will just update the current node to current node dot right, and it will just update the pointer to the right as per the code, and it will work according to our choice. Now we'll be compiling the file and we'll see if it works or not. Okay, so this program is inside this folder, tree traversal by label YT. So we have to first change the directory. So change directory we changed, and now we'll be compiling the Java file. Java compile, okay, and it got compiled. That means there is no error. And now we will run the file. So as we can see that it has printed 1 2 3 4 5. This is printing level by level. Now we want to print in order, so we'll be using this function in order traversal. System.out.println printing by in order traversal, in order iterative traversal. Okay, and now tree dot in order traversal, and now again we'll be saving the file and compiling the file, java compile, then we'll be running the file, and we can see printing by in order iterative traversal 42513. So they are printing 42513, and now we will be observing that what we got in our code. Okay, so let me change it. Okay, so we are here right now, and just notice what we got in our program. So in our program also we got the same things, that 42513, 42513. So okay, we have implemented the in-order traversal by understanding in details. Now in next session we'll be understanding how we can implement using iterative the pre-order traversal. So okay, meeting in the next.